Hello everyone, welcome back to the channel. I hope you all are doing well. In the previous video, we learned about electronic configuration. That is how electrons are arranged in different shells around the nucleus of an atom. If you haven't watched that video yet, I highly recommend checking it out first because today's topic builds directly on it. Today we are going to understand these three very important topics, that is valence electrons, valency and the octet rule. These concepts help us understand why atoms react with each other and how chemical bonds are formed. So without wasting any time, let's get started. Before moving ahead, let's quickly revise electronic configuration. So electronic configuration tells us how electrons are arranged in shells. Okay, for example, hydrogen has 1 electron, so its electronic configuration is 1. Oxygen has 8 electrons, its atomic number is 8, so its electronic configuration will be 2, 6. Sodium has 11 electrons, its atomic number is 11, so the electronic configuration will be 2, 8, 1. Keep these examples in mind because we will use them throughout this lesson. Another one was that we studied about Bohr's model, in which we learned how we make this and how do we represent the electrons of an element using different shells. So we studied about K shell, L shell, M shell and N shell, and how do we find out the number of electrons, and that these shells have increasing energy. So we studied about this. Then we studied about how we make these diagrams. So we arrange 2 electrons in the first shell because in the first shell maximum number of electrons can only be 2, and then followed by in the second orbit we can put 8 shells. So this way we learned about electronic configuration and the Bohr's model. Now in this video we'll answer 3 questions. First, what are valence electrons? What is valency? And what exactly is the octet rule? So let's begin with the first topic, valence electrons. So what are valence electrons? Look carefully at the electric configuration of sodium here. Its atomic number is 11, so its electronic configuration came out to be 2, 8, 1, and the diagram is like this. So in the last shell, this one is K shell, this is L shell, this is M shell. So in the M shell there is 1 electron. So what is valence electron? Basically the electrons present in the outermost shell are called valence electrons. So whatever shell is the outermost shell, right here it is the M shell. So whatever electrons are present in this outermost shell is the valence electron. Okay, here in the last outermost shell, in the M shell 1 electron is present, so the valence electrons will be 1. Similarly in hydrogen there is only 1 shell and in it 1 electron is present, so valence electron will be 1. Same for carbon, outermost shell 4 electrons, then valence electrons 4. Outermost shell in oxygen is 6 electrons, then 6 valence electrons. Similarly in chlorine 7, so valence electron is 7. Okay, so these the last shell, that is the last shell or the outermost shell is also called as the valence shell, and the electrons which are present in it are called valence electron. This one, the last shell is valence shell, and the electrons present are called valence electrons. So in simple words, valence electrons are present in the outermost shell of an atom. These electrons are very important because they take part in chemical reactions and help atoms combine with one another. I hope that is clear. Now let's move on to our next topic. Now, what is valency? Now we will see what is valency. Valency, in simple words, is the combining capacity of an atom. It tells us how many electrons an atom loses, gains, or shares to become stable. Okay, atoms naturally try to become stable, and most atoms become stable by completing 8 electrons in that outermost shell. And this idea will make more sense when we learn about the octet rule, but for now it tells us how many electrons an atom loses, gains, or shares. Okay, now here I have given a table of elements from atomic number 1 to 15. It is important that you remember all the elements and their atomic numbers from 1 to 20, okay, and their symbols also. So here we can see the valency or the combining capacity is written here. The valency or combining capacity depends upon the valence electrons. How? So the valency of 1, so the valency of hydrogen, it has only 1 electron in the outermost shell. It has only 1 electron, atomic number is 1, and electronic configuration is also 1. So its valency will automatically be 1. Now you can see that in helium the shell is already full, right? So in K shell you can only put 2 electrons. So it's already full, so valency will be 0 only. Now these two are exceptions, okay, these two are exceptions. Now we are going to learn a trick. Okay, so first of all, whenever the valence electron is 1, 2 or 3 or 4, it remains the same in the valency. It remains the same. Whenever the valence electron is 1, 2, 3, 4, it remains the same. Now, whenever the valence electron is 5, 6, 7, you have to subtract it from 8. So 8 minus 5 will be 3. So 3 will be its valency. Similarly 8 minus 6 will be 2, and 8 minus 7 will be 1. Now whenever there is 8 in the outermost shell, it's full. Whenever the outermost shell is full, valency will automatically become 0, which means that it is stable. Valency 0 means stable. Fine. So here valence electron is 1, 2, 3 remains same. 4 also remains same, and when it comes to 5 you have to subtract 5 from 8, 3. Similarly for 5, 6, 7 you have to subtract it. There is another trick that we can use. It goes from 1 to 20. It goes in a pattern. It goes in a pattern like 1, 0, 1, 2, 3, 4. After 4, 3 repeats. 3, 2, 1. Then 1, 0, 1, 2, 3, 4. If you notice this pattern, you can easily write the atomic number from atomic By knowing the atomic number, you can easily write the valency without the use of electronic configuration, but it's better to use electronic configuration. For example, here the valency pattern is 1 0 1 2 3 4 3 2 1 0 1 2 3 4. I hope you get that. It's a little confusing, but you'll get a hang of it. Let us also see some examples. So the valency of carbon. So carbon's atomic number is 6. So the electronic configuration will be 2, 4. 4 is the valence electron here. So 4 remains the same. We don't do anything with 4. So the valency will be 4. Followed by oxygen, let's say. Atomic number is 8, electronic configuration is 2, 6. Valence electron is 6. So 8 minus 6 we'll do 5. 8 minus 6 will be 2, sorry. 8 minus 6, 2. We get the valency 2. Now let's come to the octet rule and understand what basically is octet rule. So the octet rule states that atoms tend to gain, lose or share electrons to achieve 8 electrons in their outermost shell, making them stable like noble gases. So why 8 electrons? Why 8 electrons only? So because atoms with 8 electrons in their outermost shell are more stable. If we look at electronic configuration, then we will see that if there is 8 in the outermost shell, then it is already stable. So all elements try to become stable. So for that they gain, lose or share electrons. Okay, so that they achieve 8 electrons in their outermost shell to become stable. And all noble gases are stable. All noble gases are stable, but there is an exception that helium is stable, which is 2 electrons. This is Duplet rule. Okay, so as we just saw that here in helium, the outermost shell is filled and it is K shell. K shell only has 2 electrons, so it is already filled up and it is the valency is 0, which means that it is stable. Now why do atoms lose, gain or share electrons? So atoms choose the method that requires the least energy to become stable. So atoms lose, gain or share electrons to become stable, and they choose the method which requires the least energy. Okay, so let's see, if an atoms with valency 1, 2, 3, they lose electrons. Okay, and it is easier to lose few electrons than to gain many electrons, right? For example, let's see lithium here. So the electric configuration is 2, 1, the valency is 1. So if it loses this 1 electron, then it will require less energy and will become stable automatically, because the previous shell, the K shell, will become full. So as it will lose 1 electron, the K shell will become filled up, so it will become stable. Okay, and it is easier to lose 1 electron than to gain 7 more electrons. Okay, similarly here also the valence electron is 1, so it will lose 1 electron. Final electronic configuration will become this, and the last shell will become full. It will have 8 electrons, so it will become stable. Similarly for magnesium and aluminium, when it loses 2 and 3 electrons, it becomes stable. So whenever atoms have 1, 2 or 3 as their valency, they lose electrons. What they do? They lose electrons. Okay. Now, whenever atoms with 5, 6 or 7 as their valence electrons, okay, so what happens? They gain electrons. It is easier to gain a few electrons to become stable here than to lose these many electrons to become stable. So they gain electrons. For example, right here we have nitrogen. So its valency will be, 8 minus 5, 3. But here we are talking about valence electrons. Okay, so what will it do to become stable? It will gain 3 electrons. It will gain 3 electrons. So final configuration will be this. So it will become what? It will become stable. Similarly for oxygen, 6 is the valence electrons, then it will gain 2 electrons and become stable. Same for fluorine, it will gain 1 electron, become stable. And for chlorine also, it will gain 1 electron and become stable. Now for atoms with 4 valence electrons, what happens with the one with 4 valence electrons? They usually share electrons. Not all the time, but usually they share electrons. Gaining 4 or losing 4 electrons requires a lot of energy. So these atoms generally share with other atoms. For example, in carbon, it has 4 valence electrons. So it will share these 4 valence electrons. Similarly, in silicon, there are 4 valence electrons. So it will also share 4 electrons. Now here is the trick, that whenever the valence electron is 1, 2 or 3, it will lose electrons. Whenever the valence electrons are 4, it will share, and whenever there is 5, 6 or 7 as valence electrons, then it will gain electrons. And 8 basically means it is already stable, so no need to gain or lose or share anything. Okay, now let us see about noble gases. So why are noble gases stable? But first, why are noble gases stable? So noble gases already have completely filled outermost shell with 8 electrons. Okay, their outermost shell is already filled with 8 electrons. So they don't need to gain, lose or share electrons. For example, helium. Helium is an exception, by the way. It follows Duplet rule and is stable with only 2 electrons. So because it's already stable, its valency is 0. Okay, it's already stable. Then comes to neon. Neon has atomic number 10. So the electronic configuration is 2, 8. Last shell is already full with 8 electrons. Maximum number of electrons in the L or M and N shell is 8. So it's already filled. So the valence electron is 8. So it is complete. It follows Octet rule. Valency is 0. Whenever the valency is 0, it is already, you can say, stable. So argon, krypton, xenon, radon, all these follow this Octet rule. They are already stable. So these already stable gases, they are noble gases. Okay, so who are noble gases? We should have discussed it first, but now let's see. Elements of group 18 of the periodic table are called noble gases. I know it will be a little confusing, but right now let's just focus on this thing, that noble gases are already stable, their valencies are 0. So some important properties of noble gases, it's just a side quest, it's not very important. the noble gases are colorless, odorless and tasteless gases. Okay, they exist as single atoms. They are monoatomic, very unreactive. Due to complete outermost shell, they don't react because they don't need to gain, lose or share electrons, so they are very unreactive. Now they have very low melting point and boiling points, and they do not form compounds in normal condition. Valency of all noble gases is 0. So noble gases are the most stable element in their respective periods. Okay, so and a quick recap of whatever we studied about noble gases. So 2 valence electrons in helium, it follows Duplet rule, it is already stable. 8 valence electrons, which means other noble gases, they are stable already, so they do not gain, lose or share electrons, and valency is always 0. Now a short summary. Valence electrons, electrons in the outermost shell. Valency is the combining capacity. We also studied how to find valency and some tricks to remember valency. Then octet rule, atoms become stable by completing 8 electrons in their outermost shell. So valence electrons, electrons present in outermost shell, valency, combining capacity, and octet rule states that atoms tend to gain, lose or share electrons to achieve 8 electrons in their outermost shell to become stable. Noble gases are already stable, so they do not participate in chemical reactions. Thank you everyone. That brings us to the end of today's lesson. I hope this video helped you understand valence electrons, valency and octet rule in a simple way. If you found this video helpful, don't forget to like, share and subscribe. Also, I have added some practice questions in the pinned comment and description. Solve them on your own and let me know your answers. Thank you so much for watching. I'll see you in the next video. Take care and goodbye.